Chemical composition. Antioxidant and antimicrobial activities of Anabasis articulata methanolic extract. Muhammad F. Hafaz. Introduction. Large amount of wild medicinal plants is found in most desert lands in Egypt that can produce a wide range of chemical compounds that have many biological functions. Also, when ingested by humans, several of these plants provide long-term health benefits and treat human diseases successfully. Schwab et al. 2008. Ahmed et al. 2018. To investigate the biochemical elements responsible for the biological effects, the current study set out to 1. Characterize the chemical components of the Egyptian ecospecies of Anabasis articulata methanol extract by GCMS, and 2. Evaluate the antioxidant, antibacterial, and anti-cancer activities of Anabasis articulata methanol extract. Material and methods. 1. Anabasis articulata was gathered from a wild population in the Egyptian desert. The plant material was cleansed, air-dried for several days at room temperature until completely dry, and then ground into powder. 2. Preparation of plant extracts and phytochemical analysis of selected plant species. 3. Purification and characterization of the most active compounds by G.C. per mega Siemens. 4. Determination of the prepared extracts and active constituents for their biological activities, antimicrobial activity, antioxidant, and anti-cancer potentiality. Results and discussion. GCMS analysis. The volatile components of the methanol extract of Anabasis articulata were accurately characterized by GCMS analysis. The most abundant molecule being palmitic acid, 12.57%. Isolated after 21.65 minutes, followed by 3, 14, 16 trihydroxycard 20, 22, enolide, 7.92%, and STIGMAST5EN3OL, 3-alpha, 24S, 7.91%. The results of GC per mega Siemens analysis have also specified 4 main classes of the components categorized as fatty acids and esters, 57.78%, hydrocarbons, 23.89%, steroids, 14.84%, and terpenes, 6.46%. Antioxidant activity. According to the results, the extracts of Anabasis articulata exhibited antioxidant activity in a dose-dependent manner. P is less than or equal to 0.05, which was comparable with ascorbic acid as a reference standard. Based on the IC50 values, the aqueous extract of Anabasis articulata has an antioxidant activity of 33.64 mg per milliliter. Cytotoxic activity. The significant cytotoxic potential of Anabasis articulata having IC50 microgram per milliliter. Values 62.35 micrograms per milliliter for HEPG2 cell lines, 73.64 for MCF7 cell lines, 61.34 for PC3 cell lines, and greater than 100 microgram per milliliter for normal cells. Conclusion. Finally, the phytochemical analysis proved that Anabasis articulata were relatively rich in bioactive secondary chemical compounds. Regarding biological activity, Anabasis articulata could be a source of antioxidant, antimicrobial and cytotoxic activities.
Chemical composition, in vitro assessment of antioxidant and cytotoxic activities of methanolic extract of Avicennia marina. By Hoda Osman. Introduction. Halophytes are plants that are naturally adapted to salinity and are considered as models to understand stress tolerance in plants. To overcome harsh conditions, halophytes are synthesis of secondary metabolites, such as phenolic compounds, saponins, and alkaloids. These molecules have a crucial protective role in the plant and exhibit relevant bioactivities, including antioxidant, anti-inflammatory, and antitumoral, which are linked to beneficial therapeutic properties and could help explain the use of some halophytes in traditional medicine and as food. Avicennia marina, Forsk. Veer, one of the most abundant and common mangrove species, is used in traditional medicine for the treatment of different diseases, including rheumatism and smallpox. Material and methods. Avicennia marina was collected from coast of Red Sea of Safaga, Egypt. The plant material was cleaned, dried at room temperature for several days till complete dryness and ground into powder. Preparation of plant extracts and phytochemical analysis of selected plant species. Purification and characterization of the most active compounds by GC/MS. Results and discussion. GCMS analysis. The volatile components of the methanol extract of Avicennia marina were accurately characterized by GCMS analysis. The most abundant molecule being palmitic acid, 12.57%, isolated after 21.65 minutes, followed by 3,14,16 trihydroxycard, 20,22, enolide, 7.92%, and stigmast, 5-then-3-ol, 3-alpha, 24S, 7.91%. The results of GC/MS analysis have also specified 4 main classes of the components categorized as fatty acids and esters, 48.78%, hydrocarbons, 26.89%, steroids, 16.84%, and terpenes, 7.46%. Antioxidant activity. According to the results, the extracts Avicennia marina exhibited antioxidant activity in a dose-dependent manner, P less than or equal to 0.05, which was comparable with ascorbic acid as a reference standard. Based on the IC50 values, the aqueous extract of Avicennia marina has an antioxidant activity of 37.16 mg per milliliter. Cytotoxic activity. The significant cytotoxic potential of Avicennia marina having IC50 G/ml values 61.39 G/ml for Hep G 2 cell lines, 76.52 for MCF 7 cell lines, 60.33 for PC3 cell lines, and greater than 100 G/ml for normal cells. Conclusion. Finally, the phytochemical analysis proved that Avicennia marina were relatively rich in bioactive secondary chemical compounds. Regarding biological activity, Avicennia marina could be a source of antioxidant, antimicrobial, and cytotoxic activities.
Structure, fluorescence, and magnetic properties of chromium cation substituted cobalt, manganese, chromium ferrite nanoparticles at X from 0 up to 1 by Reham Kamal Abdelhamid, Urfat Said, Physics Department, Faculty of One for Arts, Science and Education, Professor Muhammad Ghuzza, Basic Science Department, Marj Institute of Engineering and Modern Technology. In the present work, we prepared a series of chromium substituted cobalt, manganese, chromium ferrite nanoparticles from X equal 0 up to 1 with an interval 0.2 using a sol-gel self-ignition route method. The powder calcinated at 800 degrees centigrade for 6 an hour. The structure properties of samples were carried out by XRD, FTIR, and high resolution transmission electron microscope. From the XRD results, we found that the cubic spinel structure with base group FD3M were formed for all samples with a significant ratio of hematite, which decreased gradually by increasing chromium concentration. Moreover, the chromium ion substitution caused a significant reduction in crystallite size from 44.75 to 2865 nanometers. FTIR spectrum confirms the formation of peaks corresponding to metal-oxygen bond, which shifted to higher wavelengths. From the high resolution transmission electron microscope results, it is clear that all samples will crystallize in nanoparticles with soft agglomeration, may be due to higher calcination temperature and magnetic particles. It is also observed that the particle size decreased from 62.5 to 44.17 nanometer, which in a good accordance to XRD result. Magnetic properties revealed that all magnetic properties such as saturation, magnetization, remnant, and coercive field decreased gradually by increasing chromium concentration. The saturation magnetization decreased from 67.9 to 10.5 electromagnetic unit per gram. A strong and sharp red emission observed at 600 nanometers and weak UV emission at 324 nanometers are obtained from the fluorescence spectra, which observed after excitation at 285 nanometers. The chromium substitution enhances the red emission, which has a maximum intensity observed for the sample for X at 0.5, indicating that is a less defect in the matrix due to chromium substitution.
GCMS analysis of phytocomponents in the methanol extract of Launea mucronata and its potential antioxidant and cytotoxic Yasser al Amir introduction plants have been described as the oldest friends of man due to their value as sources of food, shelter and medicines. According to estimates, by the 18th century, 80% of all medicines came from plants. Medicinal plants are an integral part of the human society for disease control, since dawn civilization. In order to investigate the biochemical elements responsible for the biological effects, the current study set out to 1. Characterize the chemical components of the Egyptian ecospecies of Launea mucronata methanol extract by GCMS, and 2. Evaluate the antioxidant, antibacterial, and anti-cancer activities of Launea mucronata methanol extract. Material and methods. 1. Launea mucronata was collected from naturally growing population in coastal desert, deltaic Mediterranean coast, of Egypt. The plant material was cleaned, dried at room temperature for several days till complete dryness and ground into powder. 2. Preparation of plant extracts and phytochemical analysis of selected plant species. 3. Purification and characterization of the most active compounds by GC per mega Siemens. 4. Determination of the prepared extracts and active constituents for their biological activities, antimicrobial activity, antioxidant, and anti-cancer potentiality. Results and discussion. GCMS analysis. The volatile components of the methanol extract of Launea mucronata were accurately characterized by GCMS analysis. The most abundant molecule being palmitic acid, 12.57%. Isolated after 21.65 minutes, followed by 3, 14, 16 TRIHYDROXYCARD 20, 22, enolide, 7.92%, and STIGMAST5EN3OL, 3-alpha, 24S, 7.91%. The results of GC per mega Siemens analysis have also specified 4 main classes of the components categorized as fatty acids and esters, 48.78%, hydrocarbons, 26.89%, steroids, 16.84%, and terpenes, 7.46%. Antioxidant activity. According to the results, the extracts of Launea mucronata exhibited antioxidant activity in a dose-dependent manner. P is less than or equal to 0.05, which was comparable with ascorbic acid as a reference standard. Based on the IC50 values, the aqueous extract of Launea mucronata has an antioxidant activity of 31.70 mg per milliliter. Cytotoxic activity. The significant cytotoxic potential of Launea mucronata having IC50 microgram per milliliter, values 59.54 micrograms per milliliter for HEPG2 cell lines, 72.47 for MCF7 cell lines, 59.90 for PC3 cell lines, and greater than 100 microgram per milliliter for normal cells. Conclusion. Finally, the phytochemical analysis proved that L. mucronata were relatively rich in bioactive secondary chemical compounds. Regarding biological activity, L. mucronata could be a source of antioxidant, antimicrobial and cytotoxic activities.
Investigation of antibacterial, anti-cancer, antioxidant, and methyl blue, MB, catalytic degradation of the biosynthesized zinc sulfide/zinc oxide nanoparticles using Fusarium oxysporum. By Aya Aboelnga 2D. Research Group, Physics Faculty of Science, Mansoura University, Mansoura, Egypt. Nanoparticles have been utilized in various fields. The synthesis of zinc oxide ZNO, zinc sulfide ZNS, and ZNO-ZNS composite nanoparticles was synthesized via Fusarium oxysporum. F. Oxysporum is a large fungus species complex composed of both plant and human pathogens. In this study, we represent the utilization of fungal extract to synthesize ZNS/ZNO composite nanoparticles. The aqueous extracts obtained from F. oxysporum were employed for this purpose. F. oxysporum was cultivated on potato dextrose agar, PDA, medium, and after the incubation period, the fungal biomass was separated from the media by filtration, and any remaining media residue was thoroughly removed by washing the collected fungal biomass 3 times in sterile distilled water. Then, 10 g of wet fungal biomass was added to 100 milliliters of a 5x103m aqueous solution of ZnSO4. 7H2O and incubated at 27 degrees Celsius, 200 rpm for 96H in dark conditions. The reaction solution was filtered, and filtrate containing nanoparticles was dried at 70 degrees Celsius overnight. The ZNS/ZNO nanocomposite was characterized using Fourier transform infrared spectroscopy, F. Good afternoon everybody. Optical, physical, and gamma ray synthesis, computational evaluation and molecular docking of nin-hydroquinoxylin Schiff-based derivatives. By Dalia Onzi. Introduction. Quinoxylines are a key area of interest for the inquiry due to its straightforward chemical production and biological actions. The antimicrobials echinomycin, actinomycin, and levomycin, the active or basic substance is quinoxylin. Problem statement: quinoxylin derivatives had been synthesized and tested as antimicrobial agents, and computational studies had been used to boost experimental results. Methodology: quinoxylin derivatives 5-AD, 7-9 were synthesized, then screening for antimicrobial activity by well diffusion method against S. typhi, K. pneumonia, B. subtilis, L. monocytogenes, E. coli, and the fungus Candida albicans. The minimum inhibitory concentration, MIC, was determined by making different concentrations of the tested compounds dissolved in DMSO. For computational studies, prediction of activity spectra for substance is online software in the drug innovation and development environment. Predict the inhibition mechanisms and the most suitable targets for the synthesized compounds by molecular autodock docking using PYRX software. The structure of ligand and its complexes were transformed into PDB file format using PyMol software. Results and discussion. 1. Synthesis and characterization of quinoxylin derivatives. The condensation reaction of indenoquinoxylene 11-1 with the corresponding aromatic amine in boiling ethanol containing a catalytic amount of glacial acetic acid afforded compounds 5-AD, where their structures were confirmed by spectroscopic analyses. The attempt to synthesis of derivative 7 and carbothiamide derivative 9 could achieve viaduct the condensation reaction of quinoxylin derivative 3 with phenyl hydrazine 6 and thiosemicarbazide 8 in scheme 1. The proton NMR spectrum of compound 5D, thiol proton appears as singlet signal at 7.46, figure 2. 2. Detection of antimicrobial activity. The compound 7 had antimicrobial effect against all organism, but other compounds had effect against some pathogens, table 1. 4. Molecular docking. By using molecular docking analysis in order to clarify the exact binding sites and to understand the mode of action for the best biologically active compounds. Based on molecular docking analysis, Table 2. The compounds have polar interaction with some amino acids as shown in Figure 3. Conclusions: 6 quinoxylin derivatives, 5-AD, 7, and 9, were synthesized and structurally confirmed through spectroscopic analyses. Computational simulation using PASS Online Predictor suggested that some compounds might have optimistic antimicrobial activities. Antimicrobial activity of quinoxylin derivatives was investigated. Compound 7 has encountered a significant antimicrobial activity. Molecular docking of the synthesized compounds shows their binding affinities, polar and hydrophobic interactions against the active pockets of bacterial and fungal protein targets. Modeling optimization synthesis of Cu/Zn bimetallic nanooxides for using in Congo red removal and control of pathogenic microorganisms by my M. Taha *1. In the last 20 years, the field of nanoscience has developed to become the promising field of nanotechnology. Nanoparticles (NPs) size are ranging from 0 to 100 nanometers diameter. Due to the unique magnetic, optical, and electrical properties of nanoparticles, there is a lot of interest in their production and applications. As a result, NPs have shown considerable promise in the field of environmental remediation. Bimetallic nanoparticles were produced by combining salts of 2 metals with the help of a reducing agent, which resulted in the production of new properties due to the synergy between the 2 metals. Green synthesis is a high-yield and eco-friendly path for the nanoparticles preparation. Problem statement. Water contamination by organic dyes and pathogenic bacteria has a negative impact on human health. Bimetallic nanoparticles are promising materials in pathogen elimination and dye removal methodology. CuO/CNO bimetallic NPs were synthesized using Fusarium oxysporum extract, and the conditions which affect the synthesis of NPs were optimized using CCD model. Antimicrobial activity was tested by well diffusion method and minimum inhibition concentration. The biosorption of Congo red (CR) dye using the biosynthesized CuO/CNO NPs was studied. The biosorption studies were carried out at different time intervals and different initial dye concentration. Results and discussion. 1. Biosynthesis of CuO/CNO bimetallic nanoparticles was occurred by using the extract of fungus Fusarium oxysporum. The optimal concentrations of bimetallic CuO/CNO NPs were pH, shaking, salt concentration and incubation time recorded values of 7, 140 rpm, 5 mm and 48 H respectively. The results were analyzed by one-way ANOVA to evaluate statistical significance for each factor. 2. CuO/CNO NPs affected gram-VE more than gram-plus VE bacteria. The inhibitory effect of NPs may be connected to DNA structural disintegration or enzyme activity disruption induced by the generation of highly reactive species like OH and O22+, where OH and O22+ damage the cell membrane and cell wall. 3. The physicochemical parameters effects on the Congo red sorption onto the biosynthesized CuO/CNO NPs were investigated. Conclusions. Bimetallic CuO/CNO nanoparticles were successfully synthesized by using a cost-effective, eco-friendly method. The biosynthesized CuO/CNO NPs has good antimicrobial activity against both gram-positive, gram-negative bacteria and fungus Candida albicans. Congo red sorption was investigated by using bimetallic CuO/CNO NPs.
Poster number 36. Presented by Dr. Hind Azat. Titled DFT Study of DJEB Epoxy Resin Nanocomposite with Functionalized G, CNT, and C60 with TiOtWO as corrosion inhibition. The aerospace environment is well known for its harsh conditions, such as high temperatures, vacuum, micrometeoroids, and space debris. Surfaces and materials exposed to this environment are suffering from corrosion. These properties have a significant impact on the design and construction of spacecraft and aircraft components. Accordingly, aerospace construction needs materials with high strength and stiffness to resist these conditions. As a result, it was proposed to improve the corrosion resistance features of DJEB epoxy resins via the addition of carbon-based nanomaterials such as fullerene, carbon nanotubes, and graphene functionalized with titanium dioxide to have a long lifetime in the aerospace environment. Molecular modeling was used to investigate the influence of nanocomposition on electrical and corrosion properties of epoxy resin using the density function theory calculations. For examining the improved characteristics, highest occupied molecular orbital and lowest unoccupied molecular orbital total dipole moment band gap energy and molecular electrostatic potential were calculated for all model structures. The results showed that functionalized G with TiOtWO is the most impacted nanocomposite with epoxy resins, as the electronic characteristics were reduced from 5.389 to 0.226 eV. Also, the corrosion parameters were calculated and confirmed an improvement according to composition. After collecting the studied parameters together, epoxy resin/G/TiOtWO nanocomposite might be employed as a corrosion inhibitor in aerospace.
This poster under title The Hydrogen Storage in Carbon Materials Review, presented by Isra Sulaiman. In this paper, hydrogen storage capacities of various carbon materials and their synthesis have been summarized and reviewed. Based on several investigations reported in the literature, it is observed that the storage of hydrogen in solid form is more suitable option to overcome the challenges like its storage and transportation. In this form, hydrogen can be stored by absorption like metal hydrides and complex hydrides, or by adsorption like carbon materials. All hydrogen storage materials presented, the carbon materials are attractive due to their high specific surface area, chemical stability, low cost, and plenty available. Initially work beginning with carbon nanotubes and has expanded to including wide range variety of sp2 hybridized carbon structures including graphene and spherical fluorines. Hydrogen adsorption carbon materials follows physical adsorption by weak van der Waals forces, which have adsorption enthalpy lower than 10 kJ per mole. The enthalpy of hydrogen adsorption should be between 20 and 30 kJ per mole. So finally, to increase the adsorption enthalpy, we should adding external elements to carbon adsorbent as transition metals, alkali and alkyne earth metals, and heteroatoms. These metals doping can resolve the problem of weak bending between hydrogen and the host materials, and thereby enhance the storage capacities. And the bending heteroatoms could turn their electronic and catalytic properties that make the carbon-based materials be prospective for this application.
بسم الله الرحمن الرحيم. I am Noura Yahya Sheikh, Assistant Lecturer at Faculty of Electronic Engineering, Menofia University. We co-doped zinc oxide nanostructures with cobalt and iron by sol-gel technique for different mole percent of cobalt and a fixed iron concentration of 5 mole percent. By using X-ray diffractometer, we noticed that the diffraction patterns match the standard card of the hexagonal zinc oxide word-side structure without any impurity phases, and the calculated crystalline size values increased with increasing cobalt concentrations. From the high-resolution transmission electron microscopy graphs, we found that the average particle size nearly close to the size obtained from XRD, ranging from 32 nanometer to 44 nanometer. It is known that pure zinc oxide is a diamagnetic material, so we doped it with transition elements to improve its magnetic behavior. By using VSM, we found that all the samples display a ferromagnetic trend at room temperature, and we returned its source to an increase in oxygen vacancies, which develop bound magnetic polarons. As shown in figure 5, the magnetization saturation and remanent magnetization are increased. We used E4991B impedance analyzer with frequency range from 1 MHz to 1 GHz to measure dielectric parameters. The dielectric constant, real part and imaginary part, decreased with an increase in cobalt concentrations. It may be owing to the small dielectric polarizability of cobalt ions compared to zinc. The conductivity also reduced by increasing the cobalt concentration. The rise in dopant concentration enhances the concentration of defect ions, which helps the creation of brain boundary defect barrier and obstructs the flow of charge carriers. From our results, we suggest our samples as an excellent candidate material for use in spintronics devices. Thank you for your listening.
Chemical composition of Phlomis flacosa essential oil and its potential antioxidant, antimicrobial and cytotoxic activities. Muhammad S. Sultan Introduction. Phlomis species have been used in folk medicine to treat a variety of conditions including diabetes, gastric ulcer, hemorrhoids, inflammation, and wounds. Sajadi et al. 2018. Phlomis flacosa is a member of the Lamiaceae family, which has over 3,000 species and 200 genera. Several research have discussed the antioxidant, antidiabetic, and honey production properties of the Lamiaceae, which grows in diverse parts of the world. El Mokasabi, 2014. Material and methods. 1. Phlomis flacosa was gathered from a wild population in the Egyptian desert. The plant material was cleansed, air-dried for several days at room temperature until completely dry, and then ground into powder. 2. Preparation of plant extracts and phytochemical analysis of selected plant species. 3. Purification and characterization of the most active compounds by GC per mega Siemens. 4. Determination of the prepared extracts and active constituents for their biological activities, antimicrobial activity, antioxidant, and anti-cancer potentiality. Results and discussion. GCMS analysis. The volatile components of the methanol extract of Phlomis flacosa were accurately characterized by GCMS analysis. The most abundant molecule being palmitic acid, 17.88%, isolated after 21.65 minutes, followed by 3, 14, 16 TRIHYDROXYCARD 20, 22, enolide, 6.28%, and STIGMAST5EN3OL, 3-alpha, 24S, 9.33%. The results of GC per mega-Siemens analysis have also specified 4 main classes of the components categorized as fatty acids and esters, 53.99%, hydrocarbons, 18.69%, steroids, 10.22%, and terpenes, 8.57%. Antioxidant activity. According to the results, the extracts of Anabasis articulata exhibited antioxidant activity in a dose-dependent manner. P is less than or equal to 0.05, which was comparable with ascorbic acid as a reference standard. Based on the IC50 values, the aqueous extract of Anabasis articulata has an antioxidant activity of 33.64 mg per milliliter. Cytotoxic activity. The significant cytotoxic potential of Phlomis flacosa having IC50 microgram per milliliter, values 66.22 micrograms per milliliter for HEPG2 cell lines, 70.51 for MCF7 cell lines, 63.59 for PC3 cell lines, and greater than 100 microgram per milliliter for normal cells. Conclusion. Finally, the phytochemical analysis proved that Phlomis flacosa was relatively rich in bioactive secondary chemical compounds. Regarding biological activity, Phlomis flacosa could be a source of antioxidant, antimicrobial and cytotoxic activities.
Optical and physical characteristics of chitosan silver vanadate nanocomposites presented by Hagar Ibrahim. In many advanced sciences, such as energy, medicine, biotechnology, and other branches, nanotechnology has become an effective and critical tool that involves the design and synthesis of materials at nanoscale levels, creating new materials with enhanced properties. Polymer-based nanocomposites have attracted considerable attention recently due to their unique physical and chemical properties, which make them promising candidates for various applications, besides their antibacterial effect. Chitosan is a natural biopolymer derived from chitin, a biopolymer found in the exoskeleton of crustaceans such as shrimp and crabs. When chitosan is combined with silver vanadate nanoparticles, it forms a polymer-based nanocomposite with enhanced physical properties and antibacterial effects. In addition, the antibacterial activity of silver vanadate nanoparticles is enhanced when incorporated into chitosan, resulting in a material with potent antibacterial properties. Chitosan with silver vanadate nanocomposite thin polymeric films were successfully synthesized via ordinary solution casting technique utilizing water as a common solvent. Variable mass fractions of the synthesized nanoparticles were added to the virgin polymeric samples. Their structure and characteristics were investigated using optical and physical characterization techniques. The morphology of silver vanadate nanorods was analyzed using transmission electron microscopy. The images revealed that the nanorods were highly uniform in size and shape, with an average length of 100 nanometers and a diameter of 20 nanometers. Exhibited a well-defined crystalline structure. Fourier transform infrared spectroscopy was utilized to analyze the functional groups in the nanocomposite material and study the interaction between the chitosan and the silver vanadate nanoparticles. In the spectral range of 400 to 4000, thin films of pure chitosan and other samples of mixed chitosan with various mass fractions of silver vanadate were assessed. With increasing silver vanadate content, an increase in band intensity at 600 cm per negative was seen. The swelling behavior of the synthesized samples was calculated by using an immersion method, in which way dry amount of each sample was immersed in 6 different buffer solutions. The graphing figure shows that the swelling ratio decreases with the increase in concentration or pH of each thin film material. The obtained results provide valuable insights into the optical properties of the composite material, which can be useful for potential medical applications. also investigated the biological and swelling ratio data of the thin film, indicating the potential of the composite material for biomedical applications. The combination of silver vanadate and chitosan matrix can be a promising candidate for various medical applications.
Hello everyone. Welcome to our 5th International Conference on Molecular Modeling and Spectroscopy. I am Medhat Ibrahim, Professor of Applied Spectroscopy, Spectroscopy Department, National Research Center. I am going to present my poster entitled Density Functional Theory Calculation for Graphene Quantum Dots Substituted with Different Transition Metals. Molecular modeling has gained popularity as an essential tool for simulating nanomaterial characteristics as well as their interactions and influences with other materials. The most prominent theory, density functional theory, could investigate the nanomaterial and the influence of modifications on it with an efficiency result that was approximately comparable to the experimental results. As a consequence, density functional theory was used to investigate the influence of transition metal doping with different patterns, such as iron and nickel, on the electronic characteristics of graphene quantum dots. Total dipole moment and band gap energy were computed to investigate the change in electronic characteristics. Furthermore, molecular electrostatic potential mapping for model structures was investigated for monitoring charge transfer, electronegativity, and reactivity. It is concluded that the structure represents graphene quantum dots in its zigzag trigonal shape substituted with iron was the most effective structure for reducing the band gap and increasing the total dipole moment. Additionally, the results also showed that increasing the number of transition metal atoms has negative impacts on graphene quantum dots response. This detailed theoretical calculation study can give an excellent basis for future material design, which might be used for hydrogen adoption and/or sensing. Thank you for your attention. If anyone has any questions, please feel free to ask.
Senses, antimicrobial, anti-tumor activity, token simulation, theoretical studies and electrochemical analysis of novel cadmium, cobalt, copper and iron complexes containing barbituric moiety. The authors are Asma Fahim, Hind Magor and Nelly Hussein Mahmoud. The combining of two ligands, barbituric and dibarbituric acid, to produce novel metal complexes with different metal chlorides in a molar ratio of 1:1:1 was studied. Furthermore, the obtained mixed complexes were confirmed through different analyses such as elemental analysis and spectral analysis investigations. Moreover, TGA analysis was utilized to study the thermal stability, whereas all kinetic parameters were derived using Coulter-Fern approach. Additionally, the crystallinity of these metals was analyzed through an XRD patterns with different potentials. The investigated complexes demonstrated excellent antimicrobial and anti-tumor activity against two different cell lines, with cobalt and copper complexes demonstrating superior activity over other complexes, as confirmed by docking analysis. In addition, the optimization of ligand and complexes on a DFT B3LY LAN L2GZ basis is used to assess their stability and determine physical descriptors, FMO orbitals, ESP and MEP. Furthermore, the electrochemical characterization and the electrocatalytic properties of metal complexes has been evaluated by using cyclic voltammetry and electrochemical impedance. The serendipitous approach revealed that when a variety of ligands are coupled with metal ions under accurately regulated conditions, the metal exhibited more flexible coordination geometries. Furthermore, a one-pot complexation technique makes it simple to combine many organic ligands with known characteristics to a single metal complex. Barbituric and dibarbiturics have some drug significance because they affect the nervous system and have biological evaluations as hypnotic drugs. Dibarbituric acid has a sulfur atom in a place of carbonyl oxygen at the C2 position, which results in increasing lipid solubility and hypnotic potency, a short half-life, quicker metabolic degradation, and a quick commensal activity. The chemical structure as well as the coordination character of the bidentate or end donor of the ligand were determined. All the analytic results were in good agreement with the postulated structures. The observed bond angles of the complexes differ from that predictable for ideal octahedral complexes. bind to a deformed octahedral geometry, with slight elongation in some bond lengths of the ligand was noticed in the complexes, which confirms the coordination of the metal to the ligand. So the conclusion, a series of metal complexes was synthesized. The molar conductivity values confirmed that all complexes are non-electrolytes. All of the new complexes have octahedral geometries. All novel compounds demonstrated considerable antimicrobial activity when compared to traditional antifungal and antibacterial drugs. Therefore, it was concluded that the newly synthesized metal complexes may be used as good biological agents. Regarding the cytotoxicity study, the cobalt and the copper showed excellent potential activity, more than other complexes, and these results were confirmed through docking simulation. The thermal stability of the complexes was determined by their high total activation energies, where iron complex is the most stable. The energies of the HOMO and LOMO orbitals of all complexes were negative, which indicates that the ligand and its metal complexes are stable. Also, their electrochemical behavior distinguishes their oxidation and reduction states and electrocatalytic activity through cyclic voltammetry and electrochemical impedance spectroscopy of metals. Thank you for all.
Hello again. I am Medhat Ibrahim. I am going to talk about theoretical study of substitution of graphene quantum dots with monovalent alkali metals. This work is in collaboration with Professor Hanan Elhays from Faculty of Women and Shams University and Dr. Hend Ezat from NIIAJ. Graphene quantum dots have received a lot of interest due to their unique features, including electrical, optical, and physiochemical features, which make them appropriate for a wide variety of applications. Tuning the graphene quantum dots bandgap by doping and/or functionalization improves the optical, electrical, and physiochemical characteristics of graphene quantum dots. To improve the electrical characteristics of graphene quantum dots, model structures simulate the effects of alkali metals such as sodium, potassium, and lithium substitution on graphene quantum dots in its different shapes, including armchair hexagonal, zigzag hexagonal, armchair trigonal, and finally zigzag trigonal. Total dipole moment, band gap energy, and molecular electrostatic potential were determined as parameters that trace the change in electronic characteristics of graphene quantum dots due to substitutions. Consequently, the results showed that armchair hexagonal graphene quantum dots substituted with 4 sodium atoms exhibited a strong reaction as a result of substitutions that improved the total dipole moment and band gap energy from 0.000 to 19.205 dB, and from 3.474 to 0.295 electron volts, respectively. Zigzag trigonal graphene quantum dots substituted with 2 potassium atoms also shifted from 0.049 to 11.205 dB and from 3.121 to 0.190 electron volts, respectively. The substitution of alkali metals on graphene quantum dots causes a major change in their electrical characteristics, and this could open the way for improved aqueous batteries. Finally, this theoretical investigation provides an empirical framework for the experimental production of new materials with applications in electrochemical energy storage, electrocatalysis, and aqueous batteries. Finally, it could be concluded that these new materials can be used in energy storage devices. Thank you for your time.
Everyone, I'm Rania Badri, Assistant Lecturer at Physics Department, Faculty of Women and Shams University. Our poster today will be about carboxymethyl cellulose sodium copper oxide zinc oxide core shell nanocomposite for skincare products. I wrote towards broadband UV filters and high refractive index materials. As we know that due to the depletion of the stratospheric ozone layer has led to a gradual increase in the UV radiation, which increases the harmful effects on human health, such as skin burn, skin cancer, and hyperpigmentation. As a result, the number of skincare products increased. Accordingly, the aim of our study is to prepare polymer nanocomposite based on CMC and copper oxide zinc oxide core shell for the efficient block of UV radiation. Thus, we prepare the core shell nanoparticles as presented in this figure using the precipitation method, and then we added the different weight percentage of the prepared core shell nanoparticles to the CMC solution using the casting method. The XRG results confirmed the amorphous nature of the prepared polymer nanocomposite due to the appearance of the broad peak at nearly 2 theta equal 20 degree. However, FTIR results confirmed the formation of the hydrogen bonding between CMC and core shell nanoparticles due to the increasing the intensity of the OH group of CMC and the intensity of the core shell searching band. However, the present figure presents the increase in the absorbance of the pure CMC with the addition of the core shell nanoparticles and the appearance of the characteristic band of pi to pi star transition of CMC and that of the core shell nanoparticles. Also, we calculated the absorption coefficient and we found that the absorption edge of a pure CMC was shifted to the lower energy region with the addition of core shell nanoparticles and confirmed the appearance of the second absorption edge. The transmittance spectra of pure CMC was found to be decreased with increasing the concentration of the core shell nanoparticles and it extended to the visible region, which is a very good result. This table presents the UV blocking percentage of pure CMC and CMC due to different concentrations of core shell nanoparticles in the 3 regions of the UV radiation. And we found that the film containing 4 weight percentage of core shell nanoparticles can block 100% of the incident UV radiation, which is a very good result. Additionally, we calculated the optical band gap using 2 models, Stokes equation and absorption spectra fitting model, and we found that the band gap decreased with increasing core shell nanoparticles concentration, and also the 2 models are consistent with each other. Additionally, we calculated the refractive index, and it was found that it increased to its value to twice its value with the addition of 4 weight percentage of core shell nanoparticles. Thus, based on the obtained results, we use this film containing 4 weight percentage of core shell nanoparticles, and we to enhance the blocking of one of the sunblocks present in the Egyptian market. We dissolve we dilute the mesh sunblock in deionized water, and then we added different concentrations of our polymer nanocomposite to this sunblock. And then we studied the transmittance of this sunblock polymer nanocomposite. We found that the transmittance of the pure sunblock decreased sharply with increasing the concentration of our polymer nanocomposite until it reaches to 100%, which is a very good result. Additionally, we calculated the sun protection factor for pure sunblock, which is found to be 5, and we found that it increases to 22.1 with the addition of 10 weight percentage of our polymer nanocomposite, which is a very good result. Which according to the published report by the World Health Organization, they recommended using sunblock with sun protection factor between 15 and 14, which is the best for using. Our conclusion is that the nanocomposite filters are suitable candidates for UV shielding applications. Thank you.
The present investigations study the effect of different solvents on the various spectroscopic and photophysical properties of malachite green dye sample to suggest its probability to act as laser dye. These include the absorption and emission cross-sections, fluorescence quantum yield, and fluorescence lifetime. In addition, the simulation of the energy gap, bond length, and IR spectrum. Firstly, from Fig. 1 and 2. In Table 1, it can be seen that in aprotic solvents, ethanol, acetone, methanol, both absorbance wavelength and fluorescence wavelength of malachite green decrease with the increase of solvent polarity. However, both absorbance wavelength and fluorescence wavelength has no evident difference in aprotic solvents, 1 for dioxane, DMF. So, all of the molar extinction coefficient, fluorescence intensity, and fluorescence quantum yield of malachite green gradually increase with the increase of solvent polarity. The UV viscount spectra of different solvents are shown in Fig. 1 in Role of point spread function and time of flight modeling in improving breast cancer Peru time/central time images using various reconstruction algorithms. By Iman El Sayed. Biophysics Research Group, Physics Department, Faculty of Science, Mansoura University, Mansoura, Egypt. Breast cancer is one of the most common cancers in women worldwide. A total of about 1.5 million women, or 25% of all women with cancer, worldwide receive a breast cancer diagnosis each year, making it one of the most prevalent malignancies among women. Mammography is less sensitive than other screening techniques like PET-CT and magnetic resonance imaging, MRI. This study aimed to evaluate the effect of the ordered subsets expectation maximization, OSEM, on breast cancer patients' Peru time/central time image quality. Also, to evaluate the effect of either point spread function, PSF, and time of flight, TOF, factors on the enhancement of the breast cancer patient's Peru time/central time images. This was done by evaluating the changes in maximum standardized uptake value, SUV max, and mean standard uptake value, SUV mean. Furthermore, metabolic tumor volume, MTV, and total lesion glycolysis, TLG, were estimated for breast cancer patients with known and definite body mass index, BMI. 50 breast lesion patients had undergone 18F fluorodeoxyglucose, FDG, Peru time/central time. The PET data were reconstructed with a baseline ordered subsets expectation maximization OSEM algorithm and reconstructed data with the point spread function PSF algorithm with TOF. The differences in SUV max and SUV mean were compared among different reconstruction algorithms. Additionally, the variation in SUV max, SUV mean, MTV, and TLG evaluated results were compared among different reconstruction algorithms for optimal OSEM plus PSF, with TOF using a General Electric (GE) workstation protocol and designed MATLAB code. To make our investigations, the SUVs were estimated at different OSEM subsets, PSF, and TOF for the GE Zellurus workstation and MATLAB code. Since SUV's value is the most intensive quantitative parameter used and is often measured for analyzing FDG PET images in routine clinical practice. Clinical examinations to assess lesion detectability with changing weight patients are necessary to confirm the clinical usefulness of the OSEM and TOF information. To improve the effectiveness of the image and reduce the noise, it was noticed that the use of the optimum OSEM subset, OSEM 30, and the PSF, PSF5, at constant TOF elevated the PET image quality. At the same time, MTV and TLG values were optimum for OSEM 30 for both the GE Zellurus workstation and MATLAB code calculations. In contrast, the obtained value of the SNR was higher for GE Zellurus workstation OSEM 30 than for MATLAB code OSEM 21 calculation. This study showed that using OSEM 30 and PSF5 at constant TOF enhanced and improved the PET image quality. This was affirmed by evaluating different parameters, i.e., SNR, MTV, and TLG. Good afternoon, everyone. Let me start by introducing myself. My name is Mena and I am a PhD student and working assistant lecturer at the Faculty of Science at Mansoura University. My topic research is the distinctive structure and biophysical features of Sol-Gel synthesized aluminosilicate glass ceramic containing cerium oxide. And I am going to talk for about 4 minutes on this subject. First, what does ceramic glass mean? Glass ceramics are inorganic and non-metallic substances formed through the managed crystallization of glasses using a variety of treatment procedures. Because of their outstanding properties, glass ceramic materials are increasingly used in a range of applications. Rare earth elements are employed in a variety of growing industrial applications. Their existence in glass compounds and ceramics impart unique material features that improve thermal stability and strength. In this study, glass ceramic was obtained by the Sol-Gel method to investigate the role of cerium oxide in the glass ceramic after various sintering temperatures on crystallization behavior, phase composition, microstructure, physical properties, as well as the roughness surface for use in biomedical applications. In the present work, obtained powdered samples were then sintered at temperatures of 550, 700, and 850 for 2 hours to obtain the corresponding glass ceramic, and then use physical measurements X-ray diffraction, FTIR spectroscopy, Raman spectroscopy, SEM, EDX, roughness surface, and physical properties. Table 1 shows the composition of the glasses studied and their shorthand names. In the section of results and discussion from XRD shown in Figure 1, the sintering temperature at 550 in sample S10, the crystal growth rate increased because contained 10 mol% of CEO2. With raising the temperature to 700, peak lines appear in samples with a greater mol% of cerium oxide rather than the 550 temperature. This tendency is accelerated by further temperature increases of up to 850. The number of nuclei, crystal growth rate, and nucleation rate all rose significantly after 850. Figure 2 X-ray of CeO2 soda-lime aluminosilicate glasses after sintering temperature 850. From FTIR shown in Figure 3, the band at 935 conjugated with the band at 1038 when temperature increased during treatment because of rearrangement of QNC units, especially in Q2 and Q3. The band at 443 increased in intensity and width with sintering due to modifier. Figure 4 FTIR spectra of CeO2 soda-lime aluminosilicate glasses sintering at 850. Raman spectra in Figure 5 of the glass ceramic show a few characteristic bands because of fused CO with increasing temperature, in addition to the rearrangement of QN in the silica network. Figure 6 shows the surface morphology of composites containing CeO2. At sintering temperature 850, the increase in the concentration of fine cerium in the composites decreases the glassy surface marginally. It is owing to the presence of crystalline cerium particles that are dispersed uniformly throughout the glass network. The images indicate a dense structure with perforations, which increases surface interaction. Figure 7 depicts the 3D topography and roughness profiles of CeO2 soda-lime aluminosilicate glass ceramic at various concentrations. Finally, the physical properties of cerium soda-lime aluminosilicate glass ceramic in Figure 8. Glass density is related to molecular weights. In our investigation, CeO2 rose at the sacrifice of NaO2 and Ca oxide, resulting in higher density. The major causes for increased packing density in the glass network are reductions in Vm and Vf. Increased density is related to the high compactness of the glass ceramic formed from the addition of CeO2, which improves the durability and hardness of the samples. Thank you. Hello everyone, now I will present my research, which is entitled Physical Studies of Bi2O3 Modified Borosilicate Glass. In this research, a glass sample of composition X Bi2O3, 60 B2O3, 10 Na2O, 30X SiO2 mole percent was prepared via melting technique. X-ray diffraction technique was applied to prove the amorphous nature of the prepared glasses. UV visible absorption spectra were measured in the range 200 to 1100 nanometers, which were applied to evaluate optical properties, including direct and indirect optical energy band gaps. Undoped glass sample is observed to exhibit strong UV absorption due to the trace iron impurities. Different physical parameters including density, molar volume, packing density, free volume, ion concentration, polaron radius, and average boron-boron distance were calculated. Infrared absorption spectra were measured in the range 4000 to 400 cm-1, which revealed the presence of both triangular and tetrahedral borate groups. And we concluded that, according to XRD, diffraction, a broad band is appeared in the range 2 = 470, and there is no any detection sharp peak, which confirm the amorphous nature of all fabricated samples. The XRD results obtained, glassy nature, indicates to the appropriate uses such as optical applications. By using FTIR measurement, some bands appeared in the fingerprint region extending from 400 to 1600 cm, as characteristic to vibrational units. The UV.vis measurement produced a peak that indicated the presence of Bi, and its strength increased with increasing Bi content. It was noticed that variation in the Bi content at expense of silicon dioxide is heavily affecting all physical parameters of the synthesized glasses. Finally, the density of all samples was determined, and it was shown that the density increased by increasing Bi2O3 content. This is because the molecular weight of Bi2O3 is larger compared to that of SiO2. Preparation and characterization of low melting transition metal oxide doped borate glass. By Iman Othman. Borate glasses are one of the most excellent glass forming materials. The covalent network of amorphous boron oxide causes considerable changes, resulting in the creation of anionic sites that accommodate the modified alkali cations. Glasses containing transition metal ions, TMS ions, have interesting optical and electrical properties, which are due to the presence of such transition metal ions in several oxidation or coordination states in the glassy matrix. Vanadium as one of the transition metal ions, can exist in glasses in 3 possible oxidation forms, namely, the trivalent, tetravalent, and the pentavalent states. X-ray diffraction technique was applied to prove the amorphous nature of the prepared glasses, a broad band is appeared, and there is no any detection sharp peak, which confirm the amorphous nature of all fabricated samples. UV visible absorption spectra were measured in the range 200 to 1100 nanometers, which were applied to evaluate optical properties, including direct and indirect optical energy band gaps. Undoped glass sample is observed to exhibit strong UV absorption due to the trace iron impurities. The presence of V3+ ions together with the other vanadium valence states, V4+, V5+, was proved by the appearance of extra visible absorption bands. By using FTIR measurement, some bands appeared in the fingerprint region extending from 400 to 1600 cm1 as characteristic to vibrational units. Different physical parameters including density, molar volume, packing density, free volume, ion concentration, polaron radius, and average boron-boron distance were calculated. Infrared absorption spectra were measured in the range 4000 to 400 cm-1, which revealed the presence of both triangular and tetrahedral borate groups.
Our poster is entitled Design and Implementation of Automatic Lighting Control System based on Optocoupler under Different Temperature Influence. In this work, automatic lighting control system based on OptoTriac of type MOC 3023 LDR and Triac type BT136 was designed and implemented to control and manage indoor lighting levels. The IV characteristics of input LED and output triac were studied. Furthermore, the illumination control system was implemented and tested at different firing angle values. In addition, the effect of ambient temperature on the behavior of OptoTriac and its parameters are tested. In this concern, IV characteristics of OptoTriac and its parameters were studied at different temperature levels, from 25 up to 100 degrees. The results show that the behavior of both input LED and output triac of OptoTriac are affected over the proposed temperature range. With an increase in temperature, the threshold value of LED decreased from 1.2 down to 1.09 volt, causing a pronounced change in both forward and reverse breakover voltage values up to 50%. Based on a remarkable change in the control system response range was recorded, whereas the initial daylight intensity of 82 up to 224 lux was shifted to higher values of 170 up to 278 lux over temperature range. Consequently, the system power consumption ratio shifted towards higher value from 49.77 up to 85.93% over the temperature range. Finally, we conclude that the increase in ambient temperature up to 100 degrees significantly affects the electrical and light parameters of the proposed system as well as its accuracy, resulting in a severe increase in system power consumption ratio by percent of 36.16%.
Structural, optical, and ESR studies of samarium ions doped sodium aluminaborate glass. The usual melt quenching technique was used to get samarium-doped sodium aluminaborate glass samples. In the earlier decades, borate glass, with its huge variability in composition, structure, and properties, promised a bright future in the field of linear and nonlinear optics and related fields. The importance of borate glasses in glass applications is their high stability, low melting temperature, high transparency, and capability of doping with large concentrations of additives. The glass as host matrix can be doped with rare earth ions in high concentration, possesses a unique structure. Rare earth ion activated materials find wide applications in display devices, lighting technology, solar cell energy conversion, and broad applications in optical areas like optical switches for laser and sensors and optical communications. So the structure and luminescent properties of rare earth dope materials have been extensively studied. In borate glasses, samarium ions were excited in the UV region, and several transitions were observed. For the current study, synthesized samples were characterized using different spectroscopic techniques, including Fourier transform infrared, UV/Vis, and X-ray diffraction. The X-ray diffraction pattern reveals the amorphous nature of all studied samples. The results of FTIR and density show that by adding samarium oxide at the expense of aluminum oxide, there is almost no change in the structure of the glass. UV/Vis spectral data reveals the presence of samarium ion characteristic band attribute for different transitions starting in the ground state 6H5/2 to their various excited states. The intensity of the absorption spectra increases as the concentration of samarium oxide increases at the expense of aluminium oxide.
My poster is entitled A Closer Look to the Factors Affecting the Switching Transient Time of Optocouplers, presented by Assistant Prof. Dr. Wafa Abdelbasit. Abstract: the significant parameter for high-speed optoelectronic switch are transient time, elapsed between the input pulse and the output pulse. So the present paper was aimed to study the factors affecting transient time, namely turn-on time, which including some of delay time and rise time, and turn-off time, which including some of storage time and full time. The experimental setup: the proposed optoelectronic switch based on optocoupler type 4N25 is often applied in many applications for providing galvanic isolation. This optocoupler consists of light-emitting diode and phototransistor. We apply a square wave from function generator and bias voltage from DC regulator power supply, and observing the input and the output waveforms on Tektronix digitizing oscilloscope to measure transient time at the same time. Also adding a resistor between the base of phototransistor and the emitter, and measuring transient times at different values of the following parameters. Results: the studied parameters or factors on transient time is the load resistance, forward current, the bias voltage, the emitter base resistance, the temperature. We represent a turn-on time on left y-axis and the turn-on time on the right y-axis. We observe that the turn-on time is slightly affected by this factor, while a turn-off time is more affected by this factor. The turn-off time is improved by decreasing the values of load resistance, the input current of the LED, and the temperature, and increasing the bias voltage given from a DC regulated power supply to the value of 5 volt. Finally, inserting a resistor between the base of phototransistor and the emitter, decreasing the full time in the range from 80 kilo ohm up to 200 kilo ohm. Up this value or below this range, the full time is increased. Thank you.